All right, we're on to area of a circle. And again, there's a formula that goes along with this. Hopefully you can use that help sheet that I have so you don't have to memorize everything. It's nice to memorize it though, so you just got it there with you. The area of a circle, I break it down like this. It's radius to the second power and then times by pi. A lot of times you're going to see it like this. It's going to be pi r squared. People will say the area of a circle is pi r squared. Pi r squared is the same thing as what I have. I just kind of break it down a little bit. We have the same things. We still have pi, which is right there, which by the way we're just going to use 3 for. And then we still have the radius here to the second power. Now when I put these two things right beside each other, it's just like we're multiplying the results of those two things. Okay, so it's really not that tough. What I like to do here, just like with the circumference ones, I like to make a little chart. I think it helps out a lot where we do radius, diameter, and area, since we're focusing on area here. Okay, so this very first one, we have a radius of 5. Halfway across the circle is 5, so I'll put that right there. Now, we really don't need the diameter to find the area of a circle, but it's always nice to know that if the radius is 5, the diameter is 10, because it's all the way across. Now we just need the area, which is pi to the second power, not pi to the second power, radius to the second power times pi. So our radius in this case is 5. So we need 5 to the second power, and then we need to times it by pi. So to shorten this up, 5 to the second power is 25. Pi is 3. We're always going to use 3 for pi. So the area of our circle is going to be 75. And again, whatever we're dealing with here, it's going to be that's how many squares of that size fit into that. So it's going to be square something, whatever you're using here. Okay. So all we did was take this. And you could use this too. It's the same thing. I could have taken 3 times 5 to the second power, which would be 25, which is still 75. All right, next example for you here. We've got our 20, which in this case, for this one, is the diameter. That's all the way across. So for our little chart, I filled it in here. To find this area of a circle, we need the radius. So we can just do that. If we know that the full circle is 20 all the way across, that's the diameter, then we should just be able to do half the circle would be the radius. So half of 20, we're left with 10. So I'll just fill 10 in there. Now, since we have all the pieces we need, we can just use our formula. Radius to the second power will just be 10 to the second power, and then we just have to times it by pi. Pi in this case is 3. So 10 to the second power is just 10 times 10, which is 100. Pi is 3. 100 times 3 is just 300. So the area of your circle is going to be 300 square units, or 300 square whatever kinds of measurements we're actually using here. Here's an example question for you where we would find the area of a circle. Let's say that there was an earthquake and everybody is affected from this earthquake from where it happened. I think what they call it would be like the epicenter, from where it happened 100 miles out in all directions. Okay, and I want to know how much land was affected by this earthquake. So what they're saying is that from where it originated at, right here, it is 100 miles in all directions. 100 miles from there, 100 miles from there, 100 miles from there. It doesn't matter. It's 100 miles in all directions for the people who are affected by this. Okay, and I want to know basically the entire land amount that was affected. So we can do this. From the epicenter to the outermost point where people are affected is 100 miles. That represents the radius. From the middle out would be the radius, so that would be 100, making the diameter all the way across 200. Okay. Now to find the area of the circle, we just need to use our formula up here. So we'll just need radius to the second power. Radius to the second power is going to be 100 to the second power. Then we'll just need to times it by pi. Okay. Pi in this case is 3. So 100 times 100, 100 to the second power. 100 times 100 is going to be, there's going to be a 1 and there's going to be 4 zeros. 1, 2, 3, 4. So we get 10,000. And then we have to times it by pi, which is 3. So our area is going to be 10,000 times 3 is going to be 30,000. That means that this whole circle that the earthquake affected, it affected 30,000 square miles. So everybody within that 30,000 square mile circle was affected by the earthquake. All right, last question I'll present to you here before you get started on your own. If we have a circular sandbox that is 20 feet across, okay, so we'll all the way across 20 feet, and that 20 feet would indicate the diameter because it's all the way across. And I have bags of sand that take up 5 square feet. So every bag of sand can fill 5 square feet of the sandbox. I want to know how many bags we need. So we're going to need to figure out the area of this and then see how many bags of sand we need. So to find the area of this, first we're going to need the radius. Diameter is 10. Diameter is 20. Radius will be 10. Okay. So now we just need to use our formula, which is pretty easy to do by now. Radius to the second power times pi. And I think we've already used these numbers before, but if the radius is 10, 10 to the second power times pi, it's going to be 10 times 10 is 100, times 3 is going to be 300. So this sandbox holds 300 square feet of sand. Okay. Now that's our area, which is good. But now we just need to go one step further and figure out how many bags of sand we need. Every 5 square feet we have, we need a bag of sand. So we basically are trying to find how many 5 feet squared fit into 300. And that's pretty simple to do. I can just do 300, cut it into 5 pieces. If you use the calculator, I know that there are 25s in 100, just like there are 20 nickels in a dollar, 25s in 100, so there would be 45s in 200, which means 65s in 300. So our answer to this question would actually be, the area is 300 feet to the second power, the answer to the question would be 60 bags. 60 bags, and they each can cover 5 feet squared. 60 times 5 gets us back to the original number of 300.